Hello everyone, and welcome to my talk about decorators in Python. My name is Haim Michael. I live in Tel Aviv. I'm a father for 2 kids, and I'm into programming for many years. You can find my online courses at Udemy. You can also find courses I develop in Hebrew at Haim Michael Pro. And you can find more information about the training services for software developers that I deliver at lifemichael.com. I'm into Python for nearly 18 years, and for me, and I guess for many others as well, this is probably the most beautiful programming language that was ever developed. So coding in Python is a true joy for me. Now, let's start with understanding what a function is in Python. So a function in Python is actually an object. So when you define a function, you indirectly create an object. So when this code is executed, an object is created, as you can see in this diagram, and that object represents a function. Now, in addition, because we named the function with the name total, it means that there is a variable that its name is total, and that variable holds the reference for that specific object that represents the function. Having a reference that a variable holds, a reference for the object that represents the function, we can assign the value of that variable to another variable, as in this code sample. In this code sample, we have the variable total, and then we have the variable f that holds the same value, which means that we can invoke the function in this specific code sample either using total or f. That also allows us to pass over the reference of a specific object that represents a function as an argument to another function we invoke, and this is something that actually happens when we use decorators. So that's why it was important for me to clarify the fact that every function in Python is represented using an object, and that object has a reference. Now, what a decorator is, what are decorators? What do we use them for? So decorators in Python allows us to add specific functionality to a function or a class we decorate, or we can use a decorator in order to cause that something will happen whenever the function will be invoked or whenever the class will be instantiated. And actually, the concept is very similar to what we are already familiar with in other programming languages. Actually, decorators in Python are very similar in their usage to attributes in C#, annotations in Java, decorators in TypeScript, and so on. Let's see a few samples for using decorators in Python. In this code sample, for instance, we have a definition for the class point, and using the data class decorator, the class point turns into a data class. So in order to turn a class into a data class, we just need to decorate that class with the data class decorator. Here in this code sample, we use the typer library in order to develop a new utility. And as you can see, we use a decorator in this code sample for marking hello and goodbye as commands to be used. Actually, typer is an excellent library for developing utilities. You will use either in the terminal, and I strongly recommend you to check it out. Check out typer.tangolo.com. It comes from the same developer that developed Fast API. Now, how do we develop a new decorator? So we can either define a function that will be used as a decorator, or we can also define a class to be used as a decorator. The first option is the preferred one. Usually, this is how decorators are developed in Python. In this code sample, you see the function foo, and foo is decorated using a decorator. So decorator is actually a function. So indirectly, what happens is that the decorator function is invoked and foo is passed over, or to be more precise, what is passed over to the decorator function is the reference to the object that represents the full function. Now, let's take a look at this code sample. When this code sample is executed, so in the beginning we have a definition for uppercase. As you can see, the first output is "we love coding." When the uppercase function is defined, nothing is printed. Only when uppercase will be invoked, then the text inside uppercase will be printed out. So the first output is the print of "we love coding." Now you see the definition of get greeting, and get greeting is decorated using uppercase, and uppercase is actually a function. So what actually happens, and I put that in a comment, is that the uppercase function is invoked, get greeting is passed over, or to be more precise, what is passed over and is assigned to the func parameter of the uppercase function is the reference to the object that represents the get greeting function. So as you can see, the next output is the text inside uppercase because uppercase function is invoked. So what actually happens is that the object that represents get greeting is created, and its reference is passed over to uppercase, and whatever uppercase returns, and in this case it returns the inner function, or to be more precise, the reference to the inner function, is now assigned to get greeting. So the only output for now is inside uppercase. Then we see the text print "we love Python." The program continues, and then when we call get greeting, and get greeting should return something, actually what is invoked is the inner function of uppercase, because as we said, get greeting was assigned with the return value when uppercase was invoked. So now the next output we get is the text inside inner, due to the invocation of inner. Inner is invoked instead of the get greeting function that was defined. So we get printed inside inner. Inside inner is printed to the screen, and then the returned value when inner is invoked is actually a manipulation on the return value when calling the original get greeting function that was defined. Now get greeting returns a text, "good morning," and the manipulation of that text is actually turning all letters into uppercase. So what is returned now and is eventually printed to the screen is "we love Python," just that in capital letters. But before that, pay attention to the fact that after inside inner is printed to the screen, we have a printing of inside greeting, because the next thing that happens is an invocation of func, which is actually an invocation of the original get greeting function. So inside greeting is printed to the screen, and then eventually we see that the return value that is printed in the last line, the return value, which is a "good morning," just that uppercase, is printed to the screen. So this is actually what happens when using a decorator. You define a function to be used as a decorator, and then you decorate another function. You decorate get greeting with that decorator, and the final result is that whatever get greeting returns in this code sample, it becomes uppercase. So the uppercase function is actually a decorator. You can attach any function that returns text, and that decorator will turn that text into capital letters. Let's take a look at the same code sample, just that now we can see a small demonstration for the objects that are created. So uppercase is actually a variable that holds the reference to the function, the function that an object that its reference is f202 represents. And then we also have the inner function. So inner is another variable that holds the reference to the inner function. This is the function that actually invoke the original get greeting, the original decorated function, and takes whatever is the output and turn it into uppercase. And we also have the getGreeting variable that in the beginning holds the reference in this demonstration of B212, which is the reference for the original function, but later getGreeting is assigned with the reference for the inner function, the function that will now take the place of the original getGreeting. So whenever getGreeting is invoked, inner is invoked instead, and inner is responsible for doing the manipulation, turning every letter into uppercase. Now we can decorate a function with parameters. It doesn't have to be a simple function without parameters. For instance, in this code sample, very similar to the previous one, we have a definition of getGreeting, but now getGreeting as a parameter. So if you want to decorate a function with a parameter, you need that to define a decorator, a function that will be used as a decorator, that its return value will be a function with a similar signature to the function you decorate. So in this code sample, getGreeting takes 2 arguments. It has 2 parameters. So if you look at the inner function is defined accordingly. So you can use the args, quarks technique, which is better as in this code sample. And then eventually when getGreeting is invoked, and it happens over here in the last line, actually what is invoked is the inner function, because having getGreeting decorated with uppercase means, and we have that in comment, calling to uppercase, passing over the original getGreeting, and then assigning the variable getGreeting with the reference that the uppercase function returns, which is the reference to the inner function. So from now on, when getGreeting is invoked, the inner function is invoked instead. And inner function is defined in such a way that it will invoke the decorated function, in this case getGreeting, and do something with its output. In this case, simply turning each letter into capital letter. So as you can see, you can decorate a function with parameters. It doesn't have to be decorating a function without parameters. Now, the decorator should be a callable object. So the simplest would be defining a function that will be used as a decorator. However, you can also define a class to be used as a decorator. And I show that over here in this code sample. Very similar to the previous code sample, we have the method greet, and greet is decorated with uppercase. However, now uppercase, as you can see, is a class we define, not a function. And we can do that, but based on my experience, most developers prefer developing new decorators by defining new functions, not new classes. But the option exists if you prefer that. This version is the same, just that maybe a bit better because I'm using here the args and quarks pattern you are probably already familiar with. Now, the magic shows up when we nest decorators. We can develop various decorators. Each decorator has its impact, and then we can nest those decorators within each other. As in this code sample, over here we have the definition for the getGreeting, and we have 2 decorators. Now, uppercase turns every letter into a capital one, and stars adds 3 stars in the beginning and in the end. Now, when using those 2 decorators, and you can see that over here getGreeting is decorated with uppercase and with stars, what happens is actually in invocation of those two decorators. One of them turn the letters into capital one, and the other add those 3 stars in the beginning and in the end. So eventually the output, as you can see, is good morning Dave, capital letters, and in addition we have 3 stars in the beginning and in the end. So we can develop a lot of decorators and use them in various combinations, and the effect would be accordingly. Now if you go over the output, you can understand the flow, the exact flow, what exactly happens when we execute this specific code. Well, this is the same code sample, but maybe a bit better, because I'm using here the args, quarks technique, or let's say pattern, which is a highly recommended pattern to use when you define functions. Now, you can also develop decorators to decorate classes. Here in this code sample, we have a class, its name is rectangle, and we decorate it with the decorator bang. And the result is that whenever rectangle is instantiated, we get bang printed out to the console. Actually, whenever we instantiate rectangle, we actually call the rectangle function, but as you can assume or understand, following the previous samples, when calling the rectangle function, we actually call the inner function. So inner function prints bang, and then it calls func, which is actually calling rectangle, and when whatever rectangle returns, this is what the inner function returns. So from now on, after the line where rectangle is decorated with the @bang, we can say that calling rectangle is actually calling the inner function. Now this is the same code sample, maybe a bit better, because I'm using here the args, quarks pattern. Now we can also develop decorators that take arguments. So if we want to develop a decorator that takes argument, it means that the function that is the decorator should be defined with parameter or parameters. So in this code sample, bang takes text, and now when I decorate rectangle, I specify that I want to pass over the text Picasso to be the value of text. And what that means is that whenever rectangle is invoked, we get a new rectangle object, but we also get the text Picasso printed to the screen. Just as in the previous code sample, in this code sample, whenever we call the rectangle function, we actually call the inner function that prints the text Picasso, in call func, which is actually instantiating rectangle, and return whatever that rectangle function returns, which is actually a reference to a new object that represents a rectangle. Now this is the same sample, basically, just that a better version, using args and quarks pattern. Let's go over a few real-world code samples. So in this code sample, we see a decorator. Its name is stopper for measuring execution time. Whenever a function is decorated with a stopper, as in this code sample, here do something is decorated with a stopper, it means that whenever do something is invoked, actually the function that will be invoked is the one that you can find inside the stopper function, the inner function. The inner function is the function that is invoked whenever do something is invoked, and the inner function is responsible for calling the decorated function, in this code sample, do something, and also measure the execution time and do something with it, like printing it to the screen, for instance. Here's another real-world code sample, a small decorator. Its name is TinyLog. Now we can decorate other functions with TinyLog, and whenever a function we decorated, in this code sample total, is invoked, actually the function that will be invoked is the function f that was defined inside tinylog and was returned when tinylog was invoked. So whenever total is invoked, f is the one that is invoked. F handles calling the decorated function, in this case total, and f is responsible for printing a logging message. Another great code sample for using decorators is using decorators when developing RESTful web services. The code becomes very clean, simple to understand. It is clear to everyone exactly each decorated function when it will be invoked. So the whole development becomes significantly simpler when using these decorators. Another real-world example is having a decorator for caching, which means improving the performance. In this code sample, we use a library that already exists, and the use of that library actually improves the performance of the decorated function. Another great sample, real-world sample that we have already mentioned is the typer library that makes it very simple developing new utilities for using in the terminal, or you can also call it a command line interface. Now let's talk about best practices when you develop your own decorators. So first, I strongly recommend using functools. Decorating that inner function that takes the place of the decorated function that will preserve the metadata of the original function, the function you decorate. That will keep things, will keep your code safer, will allow you accessing the metadata of that decorated function. Strongly recommended. I also, of course, recommend using the args, quarks pattern, a well-known pattern when you define functions in Python. Documentation. Don't skip the documentation. Even if that decorator is being used on your end only, you can never know. At some point you forget what you did. So proper documentation will help not only others, but also will help you to remember when maintaining, adding features, fixing bugs. Strongly recommended. Now, the SRP principle. SRP principle stands for Single Responsibility Principle. It means that when you develop something, that something should be should focus on whatever it should achieve, on whatever is the purpose of that something. So when you define a function, a library, a class, make sure that function, that library, that class includes code that is relevant for achieving the goal for which that class, function, or library was defined. So if you define a decorator, be focused. Make sure the decorator performs one specific task and make sure it performs it well. Meaning, don't mix between purposes of different separated decorators. Prefer having separated decorators than having one decorator that does lots of things. Having every decorator focus on a specific task will make things simpler to maintain. So keep that in mind. Another best practice is handling exceptions. If exceptions take place, handle them. Don't let them leak outside. That would be better and simpler for everyone. Don't invent the wheel. I mean, there are lots of libraries with decorators that were already developed. To develop a new one, only if there is a reason for that. So don't be in a hurry. Don't invent something that was already invented, tested. It would be a waste of time in most cases. Unit testing, don't skip the testing. Highly important to have proper unit tests when you develop a new decorator. Type hinting, of course, and you saw that in my code samples. Highly important to keep the use of type hinting and then using a linter to ensure that the types you specified, the program works accordingly. Now, a few tips for those who are doing the first steps. Learn from others. Take a look at other decorators that were developed by others. Learn, get some inspiration. Do it step by step. Start with small, simple decorators and then move forward. And take a look at what happens in other programming languages. You might get some inspiration, some ideas for decorators you might want to develop in Python. And that's it. And I thank you for listening. Feel free to be in touch with me. This is my WhatsApp number. I also want to invite you to join my meetup group. Every month there is a meetup. And also to subscribe my Python monthly review. Thank you very much and enjoy the rest of the conference.